All right, guys, we ended up last YouTube with talking about this example, which looks difficult, but really it's the same as the previous example. You have to apply mechanical energy at A. It should equal mechanical energy at B. It should equal to mechanical energy at D. No matter what is the path, like even if the object is literally moving from A to B in this kind of slide, okay, and he reach here. Let's say that this is a point. So the mechanical energy here is equal here. Regardless, for example, that the roller coaster went all the way up like this and down, it will still, but connection of course is there, okay? It will still say, we will still say that mechanical energy at A is equal mechanical energy at this point is equal mechanical energy at this point, regardless of the path that the object is going through. So even though the object, it has literally gone through a 360 degrees loop, okay, he's asking here, what is the velocity at this point? Okay, what is the velocity at this point? Okay, so how do are we gonna approach this thing? We say mechanical energy at point A should equal to mechanical energy at point B, and come down a little bit, and we have to fix our zero level, all right, to be this one. So what is the mechanical energy at point A? And here a roller coaster and its passengers have the mass of, at the bottom of the first hill, they go through 360 loop. What will be their velocity at point B? The loop. Okay, all right, guys, so it looks like this is a roller coaster, and here the object went through a free fall. It went through a free fall, you know, because it's a roller coaster, he's moving, and basically from this point the object went through a free fall. Yeah, of course, if this is an exam problem, just a second, the first, okay, yeah, if it's an exam problem, this point should be more clear so that you can really say that this is a free fall. Now assume that this is a free fall, so potential energy at point A, which is mg times 20 plus 0, because it's a free fall, is equal to, what is the height at point B? mg, and the height is 6, all right, plus half v at B square. Can you see that m really doesn't matter? We don't have to know the mass of the object. So what is vb square? You can say that it is g times 20 minus 6. I just brought this one here, and then this is all multiplied by 2 from here, right? And we want the square root for that. So if you say this is 2 times 10, or 9.8 times 20 minus 6 is 14, all right? And let's see the answer for that. I will do it with you guys. So it's 2 times 9.8 times 14 is equal, and I want the square root for 274, square root of 274 almost. So what is the answer? Almost 17. Let me see. Yeah, it is 17. No problem, no signs, nothing. You just simply apply mechanical energy conservation. Okay, and now the last problem in this chapter. Back to just our normal object here, and this object is moving under the force of 100 Newton on a horizontal surface with a friction force, and he's simply asking you, a force of 100 Newton is applied to a 10 kg box resting on a horizontal surface with coefficient of kinetic friction 0.3. The box moves a distance of 20 meters. Calculate the work done by all forces acting on the box. Calculate the work done by all forces acting on the box. So you have basically to calculate the work done by all the forces, the 10 Newton and the normal force. Guys, when it says by all forces, it means literally you have to indicate all the forces, which is the force of friction, the normal force, which is the pulling force, the normal force, and the gravitational force. All right, guys? When he say by all forces, it means you have to calculate the work done by all the forces. So again, back to the work, it is F times D. D for all of them was 20 meters, but the angle is different. How many forces are we gonna calculate? The work net, which is the total work, is work due to 100 Newton. The 100 Newton plus the work due to the friction plus the work due to the normal force plus work due to the gravitational force. All right, and what is this? It is F, which is 100, times D for all of them, it is 20, cosine the angle, this is the D and this is F. What is the angle between them? Cosine is 0 because the angle is 0, plus we have done that in the beginning of the chapter. What is the force of friction? Mu K times Fn, okay, times the distance. This is first of all the force of friction, okay, times the distance, which is 20, times the angle. What is the angle between the distance and Fn? It's 90. And what is the cosine of 90? 0. So no need even to calculate these things, right? Plus the work due to the, sorry, we did here a mistake. I hope you guys caught it when I did it. I was saying that the angle between them is 90, but it's not 90. What is the angle between the friction force and the movement of the object? The friction is always against the movement, so the angle is always between the friction force here, this is the friction force, and the displacement is 180. You see the displacement here, the friction force is completely against that, so it's 180. So this is minus 1, all right? And what is Fn? It is mg, okay, plus the work due to the normal force, which is normal force times 20, now times cosine of the 90, because this is the normal force, this is the D, so it's 90, plus the work due to the gravity, so this is 0 anyway, we don't have to calculate it, times 20, times cosine of the angle between the gravitational force and D, which is 270, and also this is 0. So there is no work done due to the normal force and the gravitational force. The only work is done by this force and the friction force, okay? And you calculate the total ones. Now it says the net work performed on the box. Now, if you really will see the net work performed on the box, let's see. This is each one. Okay? It's only due to the force itself plus the friction one. So we simply add them together. And this is the force. That is the work that has been done on the object. All right, guys? All right. And by here, we are finishing basically chapter 6. I will record one more YouTube later about chapter 6, emphasizing more on the points, okay? But for now, I am done with chapter 6. So I will end here the YouTube.